Of 25 employees, all speak French, German or both. 36% speak German and 20% speak both. If we choose one person randomly, find the probability that they speak German if they speak French and that they do not speak French if they speak German. Alright, looking at how to attack this, we know that when we draw Venn diagrams, it seems like a Venn diagram situation. We've got French, we've got German, let's label F and G, and we've got overlap because there's definitely some people that speak both. Now you can put individual members in Venn diagrams, or you can put the number of members, or you can put actual probabilities. So we could just put percentages straight in. Two ways of doing this. Let's look at both so you can see which one seems easier. French, German. Now, if we know that 20% speak both, I could put that 20% in there. And if we know that 36% speak German, now that's all together. That's not 36% speak only German, that's 36% in the German bubble. So if I've already placed 20% in that German circle, I only need 16% out here because 20 plus 16 gives me my 36. Now if everyone has to speak one of these languages and nobody's outside the bubble, if I've already got 20 and 16, that's 36, I'm going to need 64% out here. Now, this is a perfectly okay way to do this. Somebody else might say, well, hold on a minute, I know this bit of information. Why not use what we've been given? There's 25 people. So what's 20% of 25? Well, it's a fifth, isn't it? So that's 5 actual people that go in the middle there. And 36% of 25, you can put that in your calculator very quickly and see that that's 9 people that speak German. So if we've already placed 5, there must be 4 out there. Now, if we've placed 9 people and there's 25 altogether, there must be 16 that belong in this part. Both of these will help us work it out the exact same way. So, firstly we need to see what's the chance that they speak German if they speak French. Now, this tells us that what we're trying to find is the probability that they speak German, given that we already know that they have to speak French. Now, there's a couple of ways you can do this. You can use the little formula that says find the people who are in the middle of the intersection of German and French. Now you can find how many there are and do it over the number altogether that speak French. Okay? Or you could say, let's use the formula that says find the probability of being in the intersection over the probability of being in the French part. Now if you've used these probabilities, this one makes a lot of sense. But it also makes sense just to say, hey, I need to know, if we're only looking at the French speakers, we're only interested in this circle of people. There's 84% of them in there. And what's the ones that speak German? Well, just this 20%. So I've got 20% out of 84%. Now we want to answer to the nearest percentage. So if you just chuck into your calculator 20 divided by 84 and then simplify it and turn it into a percentage, it will come out as 24%. Now, doing it with numbers, probably a little bit simpler. This is the way I'd probably go for it, just because I find it easier to picture actual people and it makes it a little bit more, I don't know, easy to understand the question. So I would be saying, well, how many people speak French altogether? That's these 21 people, so I'm not interested in those. You can cover them up with your hand if you want to. And then when you say, what's the chance that they speak German just out of those? Well, these 5 speak German, so I've got 5 out of 16. And that would also give me the exact same answer. To the nearest percentage, it's going to be 24%. So that's how we do the first part. Now, people who use this formula, that's what we've pretty much done there. Or over here, if we found the number that are in the intersection over the number that are just in the French circle, that's pretty much what we did over here in this method. So both of them work just fine. Now for the second part, we've got to notice this not. What are the chances that they do not speak French if we know that they do speak German? So here we're only looking at the German speakers. We need to put a spotlight just on the German circle. If it helps you just cover the other people up and think, well, okay, I've got 9 people there. How many of them don't speak French? Well, these 5 do speak French, so those 4 don't. So for the second part, using this diagram, I'd say I've got 4 over 9. And what I've done is I've actually just found the number of people that are in the intersection over the number of people that are in G altogether. Somebody else who's using the percentages could equally get to the same thing. They're finding the probability of being in the intersection over the probability of just being in the German circle. So if the probability of being in the intersection is 20% and the probability of being in the German circle is a total of 36%, they put that in a calculator and both groups to the nearest percentage are going to find that it is roughly 44%. So two ways of doing it, both equally good, take your pick.